Ladies and gentlemen, it's 10 o'clock. A warm welcome from my side and also from Ludo's side to our today's webinar with the topic Smart Power Distribution for Commercial HVs, Features, Applications and Challenges. We are delighted that you are joined and thanks for your interest. My name is Stefan Hartmann. I believe many of you know me already. I'm working since more than 10 years for Würth Elektronik ICS. I'm responsible as an head of sales for our sales in Europe and in Asia. And I'm very happy to be the moderator of this webinar today. With me is also a very experienced colleague, Ludovic Frelin, located in our nice new building in Würth, working also more than 10 years for our company as our HV specialist, and will guide you through today's webinar to all the technical topics. So big thank you. So we appreciate your registrations and are happy to start now with the webinar. The next slide, I will give you a short background to the Würth Group for all new participants, and then we go directly to the topics. So Ludo, next slide, please. So here you see the overview of our product portfolio. So we are serving the off and on highway market, so trucks, buses, agriculture machines and construction machines. Our main purpose is the power distribution, the control and functions monitoring, and also a big trend, the sustainable future of mobility, so the electrification. And this is the topic of the webinar today. So Ludo, when you go to the next slide, please. We see in the agenda. So what we prepared are the market trends in commercial vehicle electric systems. Then we go to the design of HV PDU solutions. We look on smart features to improve the power management. And we also have a look on the challenges and how to solve this. And on the end of the webinar, we have a Q&A session where you can place your questions. You can do it also in parallel via the chat function, and then we come back to the questions at the end of the webinar. Ludo, next slide, please. So here you see an overview of the different voltage levels. So the basis is the 12 and 24 volt network, what is also used in electrified machines. And for that, we are providing our well-known central electric units or the power boxes when you have to place them outside and protected environment like the cabin, for example. These are used for lighting, infotainment, or the main power supply in 24 volt vehicles. We also have this box platform available for the 48 volt board network. So typically used vehicles are smaller, fully electrified vehicles. And when we look then, and this is today's main focus, from 60 volt up to 1000 volts. So there we are speaking in our company then from high voltage systems. So designed for fully electric vehicles with high power demands. The amounts of systems are growing. Also, the current level is growing parallel the voltage level. And this is what we would like to speak today about. When we look a little in other regions, for example, to China, so there we studied also a little the figures. So there 25% of the heavy duty trucks are already electrified. Big growth also the last year, so 175% annual growth in electrified trucks. And we will see the same trend in the next years than in Europe. Because the total cost of ownership, so this is then the background, will decrease, and in the near future electrified trucks then are really from the total cost cheaper than the diesel trucks. Then Ludo, let's jump to the next slide, please. This is then the last slide from my side. So what do we see at our company level as trends? So we have to improve the design. So the first phases of the developments are on the road or off road. So now the customers looking for compact and much lighter solutions. Very important is also modular design on the system itself, but also on the component level, and then the integration in the whole system. When we look what I mentioned before, high power, this is also what we are seeing. So the voltage level is going up. So especially big machines require now more and more up to 1000 volt DC, and then the reliable components, and especially then a good thermal management and cooling solution behind that. And last but not least, safety is a big topic. So the whole electrical system, the isolation monitoring, and then also functional safety functions inside the PDU. And we also see there is a big need, or also the wish from many of our customers, to make the PDUs smarter, so with intelligent functions, communication through CAN, then also diagnostic and function monitoring, and with the target to really have a predictive maintenance also in the PDU. And so that's from my side for the introduction and for the topics which we will discuss today. And now I'm happy to hand over to our specialist Ludo, and we speak at the end of the webinar in the Q&A session. So have fun. And thanks, Ludo.
Thank you, Stefan. And hello and welcome to everybody from my side too. So let's start with how we design a power distribution unit at Würth Elektronik ICS. We mainly use a PCB-based solution in press-fit technology. Press-fit technology is a solderless electrical connection between a component with contact pin and PCB, and then precisely pressing the contact pins into drill hole and plated through holes. This creates a gas-tight electrical connection with very low electrical resistance. As a result, HV-PDUs based on press-fit technology offer excellent durability, mechanical stability, and high current capability, ideal for electric and hybrid vehicles. We also use busbar technology, busbar or copper bars that can be press-fitted in the PCB to locally increase the current carrying capacity, or we can use conventional busbar that or combination with PCB technology to handle higher currents. Their customizable design enables a high modularity and flexible integration into existing systems. As benefits, we have gas-tight, oxidation-resistant connections without soldering, high vibration resistance and mechanical load capacity, compact design and reduction of required installation space through double-sided assembly on the PCB, or high flexibility in the PCB design as busbar connection and large cable diameters are possible. An HV-PDU is basically designed with a kind of basic components or standard components. The first one is the housing. It's needed to protect the system, the machine, and the humans because of dangerous high voltage inside. Stainless steel housings or die casting or even chill casting aluminum housing are feasible. For low power and protected environments, plastic housing can also be suitable, for example, up to 96 volts. Second component that we usually see in the PDU are the fuses. Their integration of these different fuses are directly made on the PCB through power elements. Even main fuse, in case of a BDU, so battery disconnection unit or battery junction box, or fuses to protect inverters, chargers, or auxiliaries. We have an easy integration for service and maintenance. Then the connectors. We are integrating different types of connector from different brands. When we have a busbar output of the connector that allow us to connect it directly to the PCB with these power elements, but we can also integrate cable or connectors with cables. Then contactors. We have integration of different types of contactor directly connected to the PCB with high current contacts and busbar integration depending of the contactors. Sorry. Connection of coils and auxiliary contacts with direct contact to PCB or small wire harness depending on contactor type 2. Let's see now some examples. Here you have a 600 volt DC high voltage junction box for power distribution between the charging port, batteries, and other HV components. It was designed for a bus. Components internally, we have HV connectors, one optional connector in empty space 2, bus bars between two current sensors, and also contactors to connect the rapid charger. So it's a quite simple PDU. Other type of PDU here in a tractor, we have compact and IP protected PDU for power distribution between the battery, onboard charger, and vehicle loads. Components, we have various connectors that are connected to power elements and cable lugs. From left to right, we have consumer, low voltage, onboard charger, or battery. We also integrate small fuses, 30 and 50 ampere fuse, to protect the consumers. Let's explore the key differences between a classic high voltage power distribution unit and a smart power distribution unit. This distinction is important for understanding how modern commercial EVs achieve higher safety, efficiency, and reliability. For the classic HV PDU on the left side, we have no communication interface. A basic PDU operates passively with no built-in communication capabilities. It simply distributes power as directed by an external controller. Passive monitoring. Monitoring is here limited or entirely absent. Any diagnostics or fault detection must be handled externally. No active diagnostics. There is no real-time feedback or self-diagnosis. Issues like blown fuses or faulty contactors may go undetected until a failure occurs. And then external control. Contactors and other switching elements are managed by external controller, not by the PDU itself. In case of smart HV PDU, we have usually CAN communication. A smart PDU is equipped with a CAN interface, allowing it to communicate directly with the vehicle's network and other components. Active real-time measurement. We continuously measure voltage, current, and temperature, providing real-time data for diagnostics and optimization. Status monitoring and fault detection. Smart PDU can monitor the status of fuses and contactor and detect fault as soon as they occur. Logic processing. They can process logic for vehicle functions internally, enabling more autonomous operation and faster response to issues. Insulation resistance monitoring. Smart PDU actively monitor electrical insulation resistance, enhancing safety by detecting insulation faults early. In summary, a smart PDU is proactive and connected, while a classic PDU is passive and externally controlled. Now that we have seen what sets a smart PDU apart from a basic one, let's jump ahead and look at the specific smart features that make this system more valuable. Smart features are what transform a basic PDU from a passive component into an intelligent system that actively manages, protects, and optimizes the vehicle high voltage electrical network. For measurement and diagnostics, Integrated sensor enable real-time measurement of key parameters, voltage, current, and temperature. Isolation monitoring is built to ensure electrical safety and detect insulation faults early. The system can also monitor the HVIL status and the position of opening switch, which is crucial for safe operation. Blocked contactor detection and fuse state diagnostics help to identify faults before they become critical. For the control functions, smart PDUs manage contactor switching and implement intelligent control logic, such as pre-charge and discharge management for safe voltage equalization. They monitor feedbacks of the contactors too. Communication, integration with the vehicle's network, typically via CAN bus, enables the PDU to exchange status for diagnostic data with other components. This communication is essential for coordinating system behavior and remote diagnostics. And then for the load management, smart PDUs dynamically manage power distribution based on real-time demand for vehicle components. They provide overcurrent protection and can communicate with the vehicle controller to request power reduction or activate safe emergency modes if needed. In summary, an intelligent PDU is much more than a power switchboard. It's central nervous system for the vehicle's electrical architecture, enabling advanced diagnostics, control, and communication. Next, we will look at how these features are implemented in real-world application and benefits they bring to the application. This slide highlights the advanced measurement and diagnostic capabilities integrated in our smart HVPDU. These features are essential for ensuring the safety, reliability, and efficiency of high-voltage systems in commercial electric vehicles. This demonstrator PDU performs real-time measurement of critical parameters using our controller CDM A16 that you can see on the picture on the left. Voltage, current, and temperature are continuously monitored. This enables immediate detection of abnormal conditions and support predictive maintenance strategy. Isolation monitoring is also implemented to detect insulation faults early, which is crucial for high voltage safety compliance. For the diagnostics capabilities, HVIL status and the position of opening switch are tracked to ensure that the system is safe during usage or before any service intervention. Blocked contactor detection, the system can identify if a contactor is stuck or not operating as expected, reducing the risk of failures. Fuse state diagnostics, integrated sensors allow us to monitor the health and status of the fuses in real time, enabling quick identification and replacement of blown fuses. Now let's move on the key aspect of smart PDU, the control functions. You can see here a PDU we developed for a delivery truck, integrating different types of functions. We developed here a specific controller board, which also realizes the current sensing with a shunt. This controller, you see it on the picture on the left. Contactor switching and intelligent control. This PDU enables optimized and automated switching of contactors. This ensures safe and efficient power distribution through the vehicle's high voltage system. It can be requested from vehicle through CAN or decided by the PDU itself. Pre-charge logic for voltage equalization. The PDU manages the pre-charge logic, which is safely equalized voltage before the main circuit is closed. This protects sensitive components like the contactors from inrush currents. Discharge management is also integrated, ensuring that capacitors and other high voltage elements are properly discharged after shutdown. This is vital for the safety of the operators and the service technicians. And then monitoring of feedback contacts. Finally, feedback contact allows us, or monitoring of this feedback contact allows us real-time verification of the contactor status. Any malfunction can be detected immediately, supporting preventive maintenance and system reliability. All these functions managed by the PDU itself simplify the vehicle controller, where more and more functions are always requested. Here you can find another PDU example we developed for a bus application. We have integrated here our 64P controller that you can see also on the picture. It allows to create communication gateway with the vehicle. In this case, the PDU measures the current of the different output and send it to the vehicle through the controller. The vehicle sends some message via CAN to PDU, which then activate the different contactors. In this case, the pre-charge management is done by the vehicle controller. And then final example with our demonstrator 2. Here's some function related to load management. Using the controller and the different sensors allows to manage dynamically the loads. Some power reduction can be requested to the vehicle if the PDU enter critical range. Coupling of current sensor and a fuse can also extend the overcurrent protection and cover the area that are not protected by the fuse itself. Please find the key benefits that smart features bring to HV-PDU and the vehicle. First, reliability and safety. Smart PDU enable early fault detection, making maintenance easier and more predictable. This minimizes unexpected breakdowns and reduces vehicle downtimes. Enhanced safety features ensure safe operation and extend the system's lifetime. Service efficiency is increased, allowing for faster intervention and repair. Energy efficiency and precision. Smart PDU allow precise management of power flow and system behavior. Optimized energy use protect components and extend their lifetime. The system can dynamically adjust to changing demands, improving overall efficiency. Integration and scalability. Standardized communication protocols support modular design, making upgrades and compatibility easier. Programmable controllers increase flexibility, and more function can be integrated without overloading the vehicle's controller I/O. Decentralized function control. Decentralized control reduces the risk of a complete system shutdown caused by a single central control unit failure. This enhances fault tolerance and overall system safety. Specialized controller and platform standardization allow for better knowledge of the PDU and easier implementation of new functions. In summary, smart PDUs not only improve reliability and safety, but also boost energy efficiency, enable easier integration and scalability, and provide robust decentralized control. Let's discuss now some of the key design challenges we face when developing high-voltage PDU for commercial vehicles. First of all, EMC compliance. Electromagnetic compatibility is a major concern. HV-PDU must be designed to minimize electronic interferences, both in emitted and received, to ensure safe and reliable operation of all vehicle systems and the electronic of the PDU. This involves careful layout, shielding, and grounding strategy, as well as rigorous testing to meet automotive standards. On the software integration, modern PDUs are no longer just hardware. They require sophisticated software for diagnostics, control, and communication. Integrating this software with the vehicle's overall architecture is essential, and cybersecurity is to be taken in consideration. Some critical functions will request more and more to have also functional safety. One of the most critical trends in high-voltage power distribution is advanced thermal management. As commercial vehicles move to higher power levels and faster charging, HV-PDUs must handle greater electrical loads, which generate significant heat. Effective thermal management is essential to maintain system reliability, prevent overheating, and ensure the longevity of sensitive electronic components. Modern smart PDU can use a combination of passive and active cooling strategies, such as optimized heat sinks, airflow improved, and in some cases, liquid cooling for high-power application. Thermal sensor can also be used to monitor temperatures in real time, enabling derating or shutdown if temperature exceeds safe limits. To do this, we carry out thermal simulation that allow us to understand this issue at the start of the development. I am at the end of the presentation, so thanks for your attention. Stefan, it takes over to you.
So, yeah, thanks a lot, Ludo, for the great presentation. I hope it was also interesting for our participants. Let's jump to the next slide that we can move then also to the Q&A session. Yeah, so I think before we go to the question, you see here the QR code, also the contact data from Ludovic. So please get in touch with him if you have questions, if you have requirements to discuss, or RFI and RFQs. He's the guy who can take care about the first discussions. Also the whole hopefully known sales team colleagues are available for questions. So yeah, you can scan the QR code or get in touch with Ludo or with your well-known sales colleagues. And then Ludo, I would say, let's jump to the Q&A session. Perfect. External participants, you can now give us your questions over that wait a little, so yeah, you can place it over that question mark icon on top of the yeah, go-to app. So Ludo, I think we have to wait a little.
Yeah.
What questions are coming in? Yeah, there the first question is coming. How do you deal with moisture inside the PDU? Do you use membranes according to the volume, or what are criteria?
Yes, we use venting membranes, and we calculate the volume of the PDU. So depending about the size of the PDU, we can use different types of membranes, or even put more quantity of them. But we manage that, yes.
Great. Thanks a lot. This is, I would say, a little safety-related question. What happens if there is a loss in the communication?
It depends on the vehicle strategy, but we can even evaluate different strategies. In that case, the PDU can enter a safe mode and activate different functions like contactors opening or active discharge in order to enter a safe state. But this is usually something that we are doing in collaboration with the customer and the global strategy.
Okay, thanks a lot. There is an additional question. This is also linked to that safety. Do you already have developed a functional safety controller or module?
Yes, we did. The controller I show you in the different application are not functional safety. So depending about the safety goal of the vehicle and so on, we can use that. But we already developed some customer-specific solution with functional safety controller here.
Okay, there directly comes in an additional question to the safety level, Ludo. Which level can we provide?
I need to check, but I think it was ASIL B or C.
Okay, great. Good. Any other questions? What we have to, or what we can answer? There's one. Yeah, there's one additional question. It's related to the, I guess, automotive industry RVI ATF 6949 certificated. Yes, we are. So the factory in Germany, yes. So I would say we are on time, so half hour as planned. I would say let's wait 10 seconds if an additional question comes in.
Anyway, if some additional questions are coming in, we can answer it later also per email.
Yeah. So you saw the contact data from Ludo in the slide before, or the ICS.webinar email address you can also use, and for sure we will answer the questions afterwards. Then Ludo, I would say go to the next slide. This should be then the feedback slide. Yes. So when you close the webinar, there pop up a small survey where you can give us feedback, also give us input for interesting future webinar topics. So please use that small survey. It takes not long time to help us to improve our webinars and give us ideas for the next webinars. And then I would say we are on the end of today's webinar. The last slide should be then the goodbye slide.
Yes, it is.
Yeah, perfect. So here again, you find all our contact data. So this is really funny. The year of the end is coming. So all the participants which we cannot meet in person or discuss via mail or via Teams or in any other channel, I wish all of you Merry Christmas, relaxed holiday season. It comes very soon, and then thanks for attending the webinar. Thanks for the questions, and looking forward to speak to you soon over the different channels and in the next webinar. And thanks again, Ludo, for your presentation. And
thank you, and thank you to all.
Have a nice day.